Then what happens is in that volume of that one particular slice, the key is that little piece that I got on there, it is a circle, or it's part of a cylinder. This little dude right there is like the half part of a cylinder, so this would be the full image. Well, the volume of one of those cylinders would be pi r squared h. And it might be more familiar if you put it on the side, but a volume of a cylinder, it's like a penny basically cut in half, which is kind of a small, very squished cylinder. Okay, so the next piece we're going to do is, if that's the case, and pi r squared, I forgot to tell you where that comes from. That's the area of the face of this times the height, and the height is then, you know, how thick your penny is. And so in this case, we're only doing half of it. So our volume of this one is going to be half pi r squared times h. And the cool thing is the h in us is dx, how thick it is, and the r is this distance right here, which we're going to get from our picture because we laid it across a function. And so if we go back, so here's our volume, pi r squared h, our h is dx. So here's I'm going to go back to the original slice that we had, or the slices that I laid across there. We actually can find the distance from top to bottom of any one of these particular slices. So I'm going to go with this nice green color. Here's the top. And that equation up there, since it has a y-intercept of 4, and it eventually hits 4, that's a y-intercept of 4, and it's going down 1 over 1, so that's negative x plus 4 is the equation. So what we would say is that the height, or in this case the diameter of any one of these slices is negative x, whatever x is, plus 4. Well, we want the radius, we want half of that, so negative x plus 4 is top to bottom. So for us, we're interested in how far it is from halfway across. So that's negative x plus 4 over 2, and that's our radius that we're talking about. Okay, so that goes into our equation. Ultimately, we integrate one volume of one slice, so it's 1/2, well, that's terrible color, take that back to red, 1/2 pi r squared, and then dx is our h, and instead of r squared, we're going to take and, let me get that out of there, we're going to put in that equation, negative x plus 4 over 2 squared, because that's our radius of that one slice. That's the integral we're going to work with. Let's go to the next page, and I got some of this worked out. So here it is. There's that, but what I did is I pulled the 1/2 pi out front, any constant, I pull out front. I squared the top and the bottom in this next step right here. So negative x plus 4 is still squared. The 2 squared is now 4. And then I pulled the 4 out front. Let's go with the pi over 2. So it's now pi over 8. And I expanded that binomial. Here's green. Expanded the binomial in there. Ready to integrate. And we're ready to rock and roll. Okay, so we're going to take this, the antiderivative is, you add 1 to the power and divide by it, so it's x cubed over 3. And then this 8x becomes minus 8x squared over 2, and it'll be 16x. And don't forget, you're going to get pi over 8 in front. And then you're going to put in the upper bound 4, and the lower bound 0 into this equation. So you're going to have pi over 8, and you're going to put 4 in for each of those, minus pi over 8. And you're going to plug 0 in for each of those. Which, by the way, if you put 0 in for each one of these, you get out 0, which is nice. So it's really about what you get from putting in 4 cubed over 3, minus 8 over 2 is just minus 4 times 4 squared, and then 16 times 4, if I can get that in there. Oh man, sorry, that's so tiny. But that's just what you get from plugging it in, times pi over 8. That'll give you that exact answer. All right, enjoy.